Okay. Hello guys. Okay. First of all, let me just check the properties. Yeah, it's working. The thing is, I was solving number theory a lot. I was practicing number theory a lot. Not solving much, but learning the theories and all. And so I tried this question called common divisors. As you guys know, I struggle in 1100 also, like yeah. But this question I have tried common divisors. What it says, you are in given array. You have a given array. So first of all, let me tell you, we're gonna just discuss this problem because this problem is very important, I think, and it's very interesting. What they said, and I solved it in one go, and it's just now. Like if I show you guys, see, so that's why. And it's very interesting. We have an array. Overall, we there is here is my logic. Let me show you guys. Yeah, here is my logic. So let me just tell what it is. So we're gonna have an array, for example, A1, A2, A3, and A4. And what we have to do is uh, we just have to choose a number x which divides all of our elements of array. And we have to say the count of x. Okay, the count of x. How many x's are there who divides all of its elements? So the approach is very simple. What I did is that um, so the element divides all of its elements. So that means what's the greatest value? The greatest common divisors, right? Because they ask for say a number of common divisors of all elements. So what is GCD? Because GCD is the greatest common divisor. So let's say it's G. That means G divides all of these elements. Now, if you think, then um, we can do one thing. Since GCD divides all of these elements, so if I just count how many factors GCD have, how many devices GCD have, like for example, for example, no, not for this problem. For example, I should take some example. Yeah, for 18 and 16, let me show. For 18, not 18, for 8 and 16, the GCD is what? 8, right? Yeah. So that means 8 divides both of these elements. Now, see one thing. If uh, if 8 divides both of them, then that means the factors of 8 will also gonna divide this and this. Am I right? Yes. Again, if a number is dividing a number, for example, if D divides N, that means factors of D, all factors of D will also gonna divide N, right? Yeah. Because they are like how? They are like what? Like if if this is 3, then factors of uh, D will gonna look like something D by K, right? And this, so yeah. So what are the factors of 8? These are 1, 2, 4, not 6, 8. I think 1, 2, 4, 8, right? I think yeah, 1, 2, 4, and 8. Hmm. So what is the count? The count is 4. That means the answer is 4 for this question. Why? Because देखो, uh, 8 will gonna be included here, right? Like the the greatest common divisor will also gonna be here in this array. And why it is? Because 8 is also a factor of 8 itself. Like 8 divides 8, so it's a divisor or factor of 8. 1 is always there, and 2 and 4. So the answer for this problem is 4. 1, 2, 4, and 8. And let us recheck. Let us double check if it's working or not. 1 is the answer, yes, 1 divides both of them. 2 is the answer, yes, 2 is the answer because 2 divides both of them. 4 is the answer, yeah, 4 divides both of them. 8 is the answer, yeah, 8 divides both of them. Anything more than 8 will not gonna, because obviously 9 or whatever, because that will not gonna divide the minimum limit, which is 8. And we also know GCD of A comma B is always we like I think less than or equal GCD of no, not GCD, I think minimum of a comma b. So yeah, that's also one thing. So yeah, what I did is I did the same thing. I took input, um, there's a g, and I calculated the overall g of the array. Then I call a function called count of factors, and what it does is it counts the factors of g or factors of any number. And let me just show you the count of factors function. So yeah, this is the count of factors function. Let me just explain quickly what I am doing. I think it's yeah O of root n. So yeah, it's time complexity O of square root of n. And what happens here I have an initial counter as c, which is 0 initially, and we are checking all from 1 to square root of n, and we are checking if that number, which is our n, is divisible by that number I, then count plus plus, and if I not equals to n by I, that means as we know, like if n modulo I equals 0, that means there is also one thing we can say n by I, sorry, n modulo n by I will also gonna be 0, and that's what I did. If I not equals to n by I, that means if these two are not same, like let's cancel n, and we can't cancel like this, but if this I is not equals to this, that means this is different integer, this is different integer, and if that's happened, that means this is also a factor. So if that thing happening, then C++ also. And another thing, what I should say, how this thing is working, like n by I and I. So let us say 2 is dividing 8. So okay, better thing is to write like this. For example, we have 12. So 1, 2. I'm writing the factors. Okay, 1, 2, 3, 4, 6. I think 12. Yeah. So if you see this relation, so what I am saying, for example, we are here, I is here. So if I is 2 and I is divisible by 12, yes, I is 12 mod 2 is 0. Then if 12 by 2, which is what? Which is the 6. If 6 is and these two are different numbers, for example, like here 6 and 2 are different numbers, so that means 6 is also a factor. So since it's a factor, though, so count plus plus here too. And yeah, this is what this is how we are calculating. And well, yeah, here is our answer, and it's pretty amazing, and that's why I was thinking let's make a solution of it. And since I solved it by myself, I am pretty happy to. And another thing, it's 1300. Yeah, that's the catch. I also solved one question of 1300 tomorrow also, yesterday also. Let me show you guys. The problem was, yeah, not common device. This problem, yeah, I have solved it by myself in one go. And it took me much time. Like this one was pretty simple for me at least. Yeah, and this was the problem. What it was like, we have to find such ABC. Uh, all value of ABC should be greater equal to, I think, yeah, greater equal to, and we're gonna have an in. We have to find that is there exists some ABC such that multiplying all of them will gonna give us n. And it was also a very good problem, let me tell you. And I solved this. Yeah, I'm not going with the logics. Also, like you guys can try this by yourself, and I'm showing the solution what I have written. Um, yeah, this is the solution. It's pretty big, I know. That's what she said. Whatever. Uh, this is the solution, and the functions I have called in, like this. I make them by myself by. changing something. And another thing, since I have already told you guys, like I'm grinding number theory and maths for a long, for I think 3 to 4 days. So this is all I learned. Phi function, prime factors. Okay, we all know these things, but let me show you. LPF and SPF. SPF is very important thing. Like, and sum of factors, product of factors, count of factors, and another thing. What I did is this is, now my boilerplate code looks like this. If I wanna include all of my number theory shit, then what I've already learned, then I can just do this, and all of what I learned till now, all functions will gonna come like this. And also, I have learned uh, what I think that's called extended sieve, which is very important. I think SPF. It does every operation is in log of n time. So yeah. It's also a new topic. Let me just show you guys my. I think SPF vector. Yeah, this is the function. Like how we can use our sieve and not storing true and false Boolean value. Instead of storing Boolean values, we can store integer values like least. I should say yeah, smallest prime factors, and also we can store the greatest prime factors and make some implementations and change them up and come to a solution. Yeah. So this is all for today's video. Um, yeah, that's all. And let me know that how it was. Yeah. See you. Bye bye.